All right. Well, good morning, everyone. Welcome back to AIEC's webinar weeks. We're excited to have you. Today we have Scale joining us. They're going to present to us on how EMCs are staying resilient with simplified infrastructure management. This presentation is going to last about 40-45 minutes. We'll leave a little bit of time towards the end for questions. However, if you have any questions, please submit those through the chat and we'll present those to our presenter as we go. And if we still have some time at the end, we'll also leave a little bit for Q&A there. Again, please use the chat function to submit those. When you're using the chat function, go ahead and select the drop down. Make sure you submit those questions to AIEC. We'll be sure to moderate those questions over. Real quick here, I just want to give Scale a plug. AIEC actually uses Scale for our infrastructure here. Jared will speak a little bit about this as we go on, but you know, it's a hyper-converged infrastructure, and we've been running this for a little, I think, right around 2 years now, and couldn't be happier with it. We have a 3-node cluster here at AIEC, and then we also have a single node cluster out at one of our member cooperatives for off-site data replications, and it's just absolutely been fabulous. We've enjoyed it. It's very simple to use, and I think you'll be excited to hear how all this works. And I'm sure they'll have a demo for us this morning. So without further ado, I want to introduce Jared Pexa. Jared is the lead system engineer at Scale. He's an expert in hyperconverged infrastructure and works with customers to architect hyperconverged solutions using Scale's computing HC3 product. So Jared, I'm going to go ahead and turn it over to you.
Appreciate it. I think I'm actually having some connectivity issues. Did it drop my screen share?
It did, yeah.
Okay, just give me 1 second. I'm going to join back in here. But in the interim, I will talk a little bit. So I've actually been with Scale Computing for about 2.5 years now. Prior to that, I had worked in various different technical roles, actually been in the partner community and gotten to know Scale quite well. Really liked the technology. So it was kind of a logical transition for me to join the company. Can obviously sell the tech from there. So yeah, just bear with me for a couple seconds. I'm not sure what happened to my connection, but I'm popping back into the meeting and we will get this started here shortly.
Well, while you're doing that, Jared, Ashley, why don't you share with us kind of what we have coming up today? We have 3 other webinars in today's series.
We do. Wrong button. So the next one we have coming up at 10:30 to 11:30 is distribution situational awareness provides improved system reliability and member satisfaction. This afternoon we have a couple more starting at 1 o'clock, practical integration of smart grid data. And then our last one at 2:30 this afternoon is fiber solutions for rural electric utilities. The registration on those stays open until 1 hour before the start time, but if you miss that, just shoot me an email and I will make sure that you're registered for those classes to receive your PE credits.
Thank you. All right, looks
Awesome.
Like we're ready to go.
We are ready to go. Sorry for the little technical difficulties. The Wi-Fi has been a little spotty, but anyway, so we'll go ahead and get started. So really kind of set the agenda here. What I want to do is talk obviously about some of the challenges that we see EMCs are facing, what that means to the EMCs from an infrastructure side of the house, and then how we think we can help address those from a Scale Computing perspective. So as you can see here, obviously extreme conditions from weather conditions, obviously we mentioned wildfires, et cetera, to quite literally keep the lights on, right? Also facing historically low natural gas prices and the shift that you're seeing. And that source you can see there is the National Rural Electric Cooperative Association. So what does that mean to the IT department? You can see various amounts of things listed here: increase service levels, prevent data loss, provide growth, flexibility, simplify infrastructure, and remove silos of infrastructure. And then, of course, the big one, remove costs, or reduce costs. I shouldn't say remove. You're not going to remove it completely, but reduce the cost there. So I'll kind of go through how I feel we hit each one of these different points as I go through the presentation. And then, of course, a lot of this I'll hit on again throughout the demo of the actual user interface. I think it's a lot more powerful to see it in action than to, go through a ton of slides. So I will go through a few slides here to set the stage, but then we'll really just kind of see it live in action. So for those of you that are not familiar with scale computing, this is kind of the only quote unquote marketing slide I have that has, just a little bit of information about the company. But again, for those of you who have not heard of us, this may be important. So we're headquartered out of Indianapolis, Indiana. We have R&D sitting out in San Francisco, and we do have offices, as you can see, globally. From a customer standpoint, over 3,000 customers, 10,000 systems deployed globally. And then the one other thing I like to really point out is, I don't know if anyone's heard of an NPS score. It stands for a Net Promoter Score. It's on a scale of a -100 to a +100. And really what it is a one-question survey that goes out to our current customer base that essentially asks if it would be a product that you would recommend to a colleague in the industry. So a 91 is very hard to achieve in the tech industry, so we're quite proud of that. As you'll kind of see throughout the presentation, one of the things I like to point out here from scale computing DNA perspective, you'll hear a common theme throughout this presentation of simplified management, having all of the enterprise grade features that you'd expect from your infrastructure stack built into the product. So obviously things like built-in HA, built-in disaster recovery features, all very important in today's day and age, and we'll talk through that. As you can see, we kind of play across all different industries. From a technology partnership perspective, not going to go through every single one of these, just be aware that we do have some very strong partnerships really across the board, but also in the VDI space. So I'm not going to specifically, go too far in depth on the VDI conversation, but I know VDI is, top of mind for a lot of organizations today, just with obviously COVID and everything going on. Enabling a remote workforce is, definitely top of mind for a lot of people in IT. So if that is something of interest after this, we can always have that kind of be a one-off conversation as well, specifically talking about those VDI partnerships and how they tie into scale, but we'll focus on the core product for now. So for those of you that, maybe have heard the term hyperconverged, but maybe haven't really necessarily explored it to the extent that you really know what it is, we'll just kind of start with the high level set here. So hyperconvergence is the combination of compute, storage, and the virtualization layers. So the reason I like to really call out the virtualization piece or the hypervisor layer is because that's fairly unique to scale computing. A lot of the HCI players in the market today will converge the first two pieces there. They're bringing the storage back internal to the servers and using a software layer to create a single pool of storage. That's a key component to HCI, but a lot of our competitors in the industry are still reliant on a third-party hypervisor. So whether that's VMware or Hyper-V to be bolted on top of that. For us, we're actually integrating the hypervisor into the platform as well, having a true single stack approach to virtualization. So we are that entire stack owner. With that comes a lot of benefits. So traditionally, when I'm talking to customers, most of them have an infrastructure that looks somewhat similar to this, where you have your 2, 3, 4, 5 ESXi hosts networked up to some SAN, you name your flavor, NetApp, EMC, etc. So when we start to kind of tear this apart and really look at it, again, not here to bash the way people have done things traditionally for years. I used to architect these solutions. But when you start to kind of tear it apart, there's a lot of complexity and really unneeded complexity in the virtualization stack. I mean, really, if you look at the whole life cycle of deploying something like this, the actual deployment process is fairly complex. And then the ongoing management as well, because you're dealing with, at a minimum, 3 different vendors in this stack, likely more. You're talking some network vendor here, your VMware, whatever your host infrastructure is from a vendor standpoint, and then of course your SAN as well. So it's very often that I'm talking to customers that have dealt with the old finger pointing adage of, hey, I have an issue, I maybe updated to the latest ESXi version, and now it's not communicating with my SAN, and opening up support tickets with one vendor and then potentially having that vendor point a finger back to a different vendor saying this doesn't sound like our issue. And with that can create a lot of frustration and really you having to kind of take ownership and play essentially quarterback, and potentially try to get multiple vendors to work together, which we all know is not an easy task. Along with this also, if you look at it purely from a technical perspective, the IO path here of doing something as trivial as changing a period to a comma and hitting save is a total of 7 jumps, 7 IO to do that. So, I mean, not the most efficient from just an architectural standpoint as well. So what did we do? We wanted to eliminate all that complexity. And again, when we talk about scale computing, if you're trying to envision what this literally is, if this is the first time you've heard of us, I mean, we're talking 1 or 2 U nodes. We use the terminology nodes in the HCI world, but really what it is it's a host server. But 1 or 2 U nodes, a minimum of 3 for high availability. We have flexibility around single node configurations, which I'll talk about in a little bit. But you're talking 2 or 3, 1 or 2 U nodes in a rack, networked up, and it's all encompassed. Everything that you need to run your virtualization stack is right there. So again, from an IO path, if we compare it versus the traditional architecture, when I said that's 7 hops, for us, that's 3 hops. We're literally coming down from application of RAM down committed to disk and then written redundantly across the backplane network, written redundantly to another disk on another node. So from a redundancy standpoint, of course, that's a key component of HCI and scale computing as a whole. We are wide striping and mirroring the data across all the physical disks in the system, wide striping so we're able to take advantage of all of the IO of the physical disks in the system, and then mirroring for redundancy's sake. Another thing to point out here is another kind of technology difference versus how we compare to the other HCI players in the industry. There's really 2 paths that companies chose to take to market for HCI. The one on the left is the virtual storage appliance model, VSA model. You may have heard that coined before, or virtual SAN appliance potentially. And again, not here to bash competition. This model's fine, it works, but where it does have its deficiencies is really around the resource overhead. So some of our competitors in the industry will call this VSA that has to run on each one of the nodes something different, like a controller VM or an Omni controller, or virtual controller. But when you start to tear that apart, at a minimum, you're talking about 4 cores and 32 gigs of RAM assigned to each one of those VSAs, just to make the technology stack work. So when you're talking about, maybe small business or even remote locations where you have a multitude of locations that have to run that overhead, that you really start to deal with a cost multiplier there. So again, 3 node stack here on the left, at a minimum 96 gigs of RAM and 12 cores consumed. On our model, the integrated hypervisor model, maybe you've heard of this term, the in-kernel approach. That same architecture in our model is consuming less than 12 gigs of RAM and a fraction of a core. So again, if you really compare that to, an SMB data center, I've seen customers that are running their entire environments, maybe a handful, 10, 12 VMs on, 128 gigs of RAM, where you'd have to essentially double the hardware you're buying in that left-hand model versus what we offer in that right-hand model. So again, I'm not going to just read all these off, just some high-level kind of key points that I want to talk about here. From a simplicity standpoint, when I say it deploys in less than an hour, that's the truth. I've done these deployments across the Midwest. really the longest process is getting it out of the box into the rack and stack. After that, you're literally just assigning IP addresses to each one of the nodes in the cluster, and then doing one command that says initialize cluster. You're up and running. When I do these deployments, I get on site at 9 o'clock. By noon, we're uploading ISOs, building new VMs, or even kicking off migrations from whatever environment that customer might be coming from. From a scalability perspective, I mentioned this, we do have the ability to support single node configurations. So there's a couple different use cases when we talk about single nodes. I think I have a slide dedicated to that, so we'll talk about that in a bit more detail in a couple minutes here. From a scale out perspective, you have the ability to mix and match nodes, and you always have nodes that are backwards compatible, which is very important in this marketplace because you don't want to ever have to deal with a rip and replace type of a model. And none of our customers do once they've made the jump over to scale. It's very common that we're, maybe 3 years into a scale cluster and we're looking at years 5, 6, and 7 and looking at what that go forward path is going to look like. And what that generally looks like is rather than, hey, year 5, I'm going to rip out my whole cluster and replace it with a new cluster. Although some customers do choose to do it that way, most don't. Most are looking at, hey, year 5, I'm going to budget for a new node. Year 6, I'm going to budget for a new node. Year 7, I'm going to budget for a new node. And what we essentially accomplish there is a rolling refresh where we're constantly putting in new gear and then maybe ejecting old gear from the cluster and never having to rip and replace everything all at once. From an affordability standpoint, since we are the entire stack owner, again, including that hypervisor into the platform as well, there is no a la carte, or additional licensing that you need to go acquire to run HC3, all baked into the product. So eliminating the VTax is something that's usually a good thing for a lot of our customers. Also, we took a approach to the market where we don't have different flavors of licensing options out there. So we don't have, a starter pack, an ultimate, and a premium edition of our licensing. Whether we're talking about, one of our cheapest clusters at, 25 grand or a $500,000 cluster, all of the software features are the same regardless. So there is no different levels there. Same goes for support. We only have one level of support, and that's 24/7. So if we talk about backup and disaster recovery with scale, this is where the story starts to really hit home for a lot of our current customers. So it's very often that I actually go into a customer conversation and we're really only focused about the production cluster or their production environment, I should say, and replacing that. But by the time I get through the demo and show them what's built into the scale platform, it's very often that we're looking at some piece of DR as well. So what you see here, site 1 and site 2, there's a lot of different ways that people can configure their DR site. So we have some customers that mirror everything. So they might have a 3-node cluster in production and a 3-node cluster in DR using the built-in scale replication to replicate from site 1 to site 2. A lot of our customers, unfortunately, can't necessarily put the same exact hardware in DR that they have in their production site. So a lot of times what we look at is, excuse me, kind of a 3-to-1 setup where we have three nodes highly available in production and then maybe a single node in DR. And that single node would be right sized for the ability to replicate all the virtual machines over, but then, we'll go through an exercise and identify what's truly mission critical, what really needs to be running in a DR scenario. And then we'll develop that from a compute perspective to just run those mission critical workloads. And that usually ends up being a pretty price attractive option that a lot of customers go for. So on top of that, we do have a cloud-based offering for disaster recovery as a service. We call that Cloud Unity. And then also we do have the ability to integrate with other third-party backup products, any third-party backup product from an agent-based perspective. We specifically have relationships with Acronis that, again, I can get into more detail if that is of interest for anyone towards the end of the conversation, but where we have agentless offerings with Acronis. And then, of course, we have the ability to essentially create backup appliances where we're have a single scale node running the Acronis management server and using that local storage to essentially create a backup appliance. Again, the single node configuration, a lot of flexibility here. Generally speaking, the one use case I already talked about is where we're using that as a DR target. The other one is when we're talking about customers that have a multitude of locations. I have a company down in Iowa, a healthcare company that actually had, I think it was 22 sites where they're running a single node out at those 22 sites, just basic services, you know, domain controller, file print, a few other things. And then they're replicating all of those back to the mothership cluster to protect all that data being generated out at those edge locations. So for those locations that don't necessarily need HA, but you need local compute there, the single node configuration is a good option. Now, I'd be remiss if I didn't talk about our support team. You know, one of the things I led off the conversation with was that NPS score of a 91. I think really two main reasons why we have such a good NPS score is one, you know, from an ease of management perspective on the virtual infrastructure side of the house, you know, customers generally appreciate that, like that. But then secondarily, if they do ever have to deal with our support team, that's generally a positive experience. I like to talk about our support team as a positive experience and really almost as an extension of the company, the end user's own IT staff. So as you can see here, we offer a multitude of different services that we can include as well as the support itself. So here I just wanted to give, just as a final slide here, kind of the whole picture of the Scale product family. So we have offerings all the way from the micro appliances that are targeted for our edge locations all the way up to the core. So just to give you an idea here, the HE150 series that you're seeing over here on the left, these are based off of Intel NUCs. So, I mean, we're talking very, very small form factor here, and we can cluster those up, create a highly available cluster. Again, a very interesting use case for sites that maybe you traditionally would put a single VMware Hyper-V host at, you know, didn't have the luxury or the budget to look at something that would be highly available. And now having an option for these micro appliances to replace those traditional, you know, one host setups at a similar price point becomes very attractive for our customer base. And then on the high end side of things, of course, we have our HC3250 that is actually based on all NVMe SSD, you know, really targeted towards high performance computing and VDI deployments as well. So as you can see, we can kind of fit literally from the small to the small to the very large. So with that, I want to go ahead and jump over to the user interface here. So like I said, not one to really enjoy going through an hour's worth of slides. I think everyone would be probably sleeping by the end of that. So hopefully this will create a little bit of attention here. So what are we looking at here? This is the Scale user interface. How do you access it? Well, first things first, you simply need a web browser. I happen to be using Google Chrome here. You point that web browser to any one of the IP addresses of the nodes in the cluster. So I happen to be pointed to the first node in the cluster here, .10, but I can point to 11 or 12. It doesn't matter. We take what we call a distributed management model, meaning that there is no master node in the cluster, no single node where if you lose that node, you're going to lose the management capabilities. That also eliminates, you know, the need for a server to run anywhere on the cluster or outside of the cluster for management capabilities, aka a vCenter server, or in the Hyper-V world, it's the system center manager for VMs. Again, all the management capabilities are built right into the nodes themselves. As we move down here, these green dials are what I like to call the heads-up displays, kind of the tachometers of the cluster, if you will. Everything you would expect to see here: CPU, RAM, disk, I/O, latency. If you want to dive into disk utilization a little bit deeper, you simply click on the disk dial. You'll get a breakdown of, you know, what you have from a free perspective, what you're actually using on VM data versus what you're using on snapshots. Efficiency will show you what deduplication is saving you on the cluster. And then last but not least, provision will show you hypothetically if all of your thin provision disks filled up, where you net out to. But of course, we have automatic threshold notifications that go out. Some of them are just informational notices saying you've hit a certain threshold. Obviously, as you get to very high amounts of utilization, then those will become less informational, more of a warning. Those alerts, warnings, notices flow through in the upper right-hand corner here. As you can see, we have a healthy cluster right now. We don't expect customers to be sitting in here looking at the Scale UI at all times. So during initial configuration, you'd set that up under settings to have one or multiple email or recipients here, so you can get those alerts sent out directly to you. As we move down here, these black, gray, and white boxes are representative of the nodes in the cluster. So we have a 3-node cluster here. This is a real cluster sitting out in Indianapolis. This isn't emulated or anything. We have a couple different views here. First view is the RAM view. Pretty straightforward. Gray space is the available RAM. The white boxes are the individual virtual machines on the particular node. But of course, if you're dealing with 100 VMs, you don't want to sit and move your little pointer around to find out the name or where a VM is living. A much easier way would be to come down to your actual VM tiles down here. Here's where you can go ahead. If they're gray, they're powered off. White means they're powered on. But if you want to find out where a particular virtual machine is living, simply click on the Move VM button here, and it's going to go ahead and highlight it for you. That's not a very good example because that's a bigger one. But if we click on this particular machine here, the CentOS 8 machine, you can see it's blue right there. It's highlighting it. It's living over here on node 3. If I want to live migrate this to node 1 or node 2, I simply point and click. You can see now it's kicking off that live migration process to move that from node 3 over to node 1. The second view that we have here is the disk view. Again, pretty straightforward. It's going to give you the physical drive disk slots, what's in them, and how much capacity is being utilized. One thing I like to point out here is we do have a multitude of configuration options. Everything from still having some all spinning disk offerings that are kind of targeted more towards that backup appliance, all the way to the high end where we're talking about all NVMe based SSD, and everything in between, where a lot of our customers end up fitting is somewhat similar to what you're seeing on the screen, which is our hybrid offerings. Within our hybrid offerings, we offer a pretty cool technology called HEAT. It stands for Hypercore Enhanced Automated Tiering. And it's doing exactly what it sounds like it would be doing. It's automatically up tiering or down tiering data blocks dependent on how frequently accessed data is. So the net of that is your hot data will be living on the SSD tier, cool or cold data on the spinning disk tier. There is some tunability that you have as an admin that I'll show you when it comes to that heat setting. So just keep that as kind of a teaser. And I'll show you what I'm talking about here when I get to building a VM. Now, quite frankly, a lot of our customers just minimize this because, again, the whole idea from a scale perspective is to have basically your own kind of public cloud feel, but on premise, where you just have your resources. You don't have to worry about the underlying workings like your traditional VMware setups where you're creating runs and data stores and all of that. Literally, you configure when you set up Scale and you run that initialize cluster command, you're going to be looking at this user interface ready to, like I said, upload ISOs or, start the migration process from your existing environment and not have to worry about the underlying workings. So that's why, like I said, a lot of customers will just minimize this and worry about what actually matters, which are the individual workloads and applications moving the business forward. So now, of course, we have customers that once they've made the jump over to Scale, they'll create some template machines here. You can see we have a 2016, a 2019, and a Windows 10 machine here. This is kind of the short way of creating a VM. Once you've ran all the updates, have sysprep run, you can simply click on the clone button, rename it, redescribe it, retag it. We'll talk about tags in a little bit more detail here in a little bit. Do whatever you need to do to the machine and then go ahead and clone. So that, is literally done in 2 clicks. Important to note too, when I do create a clone of this machine, it's not consuming any more capacity from a disk utilization perspective. Our clones are thin clones. We already have the data blocks present from this template. So there's no need to consume more data here besides the small amount of metadata, obviously, to reference the new VM here. So then you could go ahead and install the applications, power this machine on. But that's the short way of creating a VM. I'll kind of show you the long way of creating a VM, if you can say that. So I'm going to come back up to my little tag here. So you see these blue boxes. If you're wondering what these are just what we call groups, logical groupings of virtual machines. You can use that however you see fit to create your different groups. But we're going to go ahead and create a new machine here, and we'll call this AIEC demo, and then we'll give it a description. Let's say hypothetically this is some sort of SQL workload. And then tags. So the first tag that you give it, like I mentioned, is going to be the actual group, but you can give additional tags after that. So if I wanted to also tag it by SQL, you'll see it's not the blue group anymore. It's just the gray SQL, but that still does serve a purpose. For example, if you wanted to then use the filter function and filter down by any machine that was tagged as SQL, it would only present the VMs that were tagged as SQL. At that point, you could just use that for sorting and finding a VM, or you could use that now that I've filtered down to maybe the 5 VMs that are tagged as SQL. Maybe I want to take a group action. Maybe I wanted to take a snapshot of all those machines. Maybe I wanted to create a clone of all those machines or power down all those machines. A multitude of options from a group action perspective. Come down to OS, a very basic choice here. If it's a Windows-based OS, leave it on Windows. If it's any Linux box or anything, go ahead and select other there. Then we come down to just typical virtual resource allocations. So let's say 4 vCPU, 12 gigs of RAM, maybe an 80 gig drive for the system drive, maybe a 300 gig drive for logs, since this is hypothetically a SQL box, and maybe a terabyte data drive. Again, all disk is thin provision. So again, we're not going to consume any capacity until data is actually written here. Then we come down here and select what we want to boot from. So the purpose of this demo, let's say we want to boot from server 2019 here, and go ahead and click create. Now it should flow under this Jared tag, and there it is being created. You're probably wondering, where did that list of ISOs come from? Where do I upload those so that they're available? So I'll show you that quickly. You jump to Control Center here. I clicked on that pretty quickly. So it's this little gear up here. Click on that, and then you'll get your list of options here. And then simply come down to Media. And you can drag and drop your ISOs right here, or upload them via a path as well. So if we needed to make any additional changes to this machine, of course we could, but let's just say it's ready to be powered up. We'll go ahead and hit the power button, and while that's powering up, I'm actually going to jump back up here to the RAM view. So I'm going to guess it's going to fire up here on node 3, because behind the scenes we are running state machines, monitoring thousands of different states or conditions cluster-wide, and that's really how we were able to develop a self-healing, self-remediating cluster. Understanding when to do things like failing over to a redundant NIC, when to fail over virtual machines in a node failure scenario, among other things. But it's also monitoring node by node resource utilization. So that's why I said I was going to guess it was going to fire up here on node 3. It did. You can see it down there. Is because it's going to look and monitor and say, okay, which node is it the best node to start up on? Biggest driver behind that's going to be available compute resources. This machine, or this particular node, was pretty light on VM, so I guessed it was going to start up here on node 3. But again, like I mentioned previously, if for whatever reason, for maybe affinity or anti-affinity purposes, you don't want it on that particular node, you could simply go ahead and click the move button and kick off that live migration process to move it to one of the other 2 nodes in the cluster. So if we, of course, we have our power options in the upper left-hand corner, and we have our default view here, which is our summary view. This has kind of live statistics of what's going on in the virtual machine at that point in time. In between the power options and that live view here, or the summary view, we have the console view. So if I go ahead and click on that, that'll prompt open a new window with the console. See the wonderful Windows loading screen here. I will say our console is pretty usable. I use it quite extensively when I'm doing any kind of work in the guest, but we can maybe jump back to that once that's loaded, and I'll click through and kick off the Windows install. Then we move down here to devices. This is going to have what we've allocated from a resource perspective. This has obviously what we're booting from. Our scale tools ISO includes our in-guest tools. And then here we have the virtual drives that we created. So when I was talking about any type of storage or nodes clusters that we offer that have 2 tiers of storage, in this case, the SSD and spinning disk, we get this cool little ability to make adjustments to that heat setting. So again, that's our tiering setting. So what I did here was went ahead and clicked more next to any of the virtual drives. That prompts open a new window, and we get this slider. So when we make adjustments to the slider, what we're really doing is we're essentially setting the relative priority access to the SSD tier versus all the other virtual disks in the system. So here I can either down tier, saying I want to give it less priority access to the SSD tier if it's something, you know, maybe a workload that maybe it's a test dev box or something that you just, you know, don't really care if it's, you know, high performing, or you don't want it to be consuming any of your SSD tier, you can start to turn it down. Or on the flip side, maybe it's something that's very high priority and you want to turn that priority up. So we have all these settings going all the way from 1 to 10 that I like to call our non-absolute settings, meaning we're not pinning it one way or the other, but we're obviously making relative adjustments. But we also have 2 settings that are pinning it. So going all the way to off would be pinning it to the spinning disk tier, or going all the way up to 11 would be pinning it to the SSD tier. So again, we have the ability to be very granular on how we use this tier of storage. In this case, the SSD tier. I had, you know, just a quick example. I had a customer actually come to me about a year ago that was convinced they needed an all-flash cluster. After we did an analysis of their environment, it was determined that they did not. We ran an analysis for, I think it was 7 days, looked at their environment. Long story short, we ended up putting in a hybrid cluster, but they had some workloads that they knew right off the bat they wanted to pin to the SSD tier. So we just accommodated that. We made sure that we had a large enough SSD pool in the hybrid deployment, and they went ahead, and as soon as they migrated those machines over, they went ahead and pinned those particular machines to 11, or pin them to SSD. So a couple other things here for just basic VM lifecycle management. If you need to hot add a virtual drive, you can do that. You just click on the little add drive button here, type in the new capacity, or type in the capacity of the drive you want to add. Go ahead and click create. A couple seconds later, we'll see that 4th drive pop in here. Same goes for expanding drives. So you just go ahead and click more, type in the capacity that you want to expand the drive to, and go ahead and click update. We'll see that change from 300 to 500 there. All right, so probably my favorite piece to talk about from a scale perspective is what we have built in from a data protection standpoint. So if we look at this particular machine, of course, at this point, we haven't done any kind of set up any schedules or anything, so I like that. So we don't have any data protection points at this point. If we wanted to take a manual data protection point, a manual snapshot, we just go ahead and click the camera button, give it a name, go ahead and click enter. A couple seconds later, we'll have a snapshot here. Again, our snapshots are what I call thin snapshots. You know, if we compare it versus traditional virtualization providers built-in snapshots, so VMware. Any VMware admin that I've spoken to says they may use VMware snaps in a limited fashion, maybe right before an application update, but they're not going to really be using that as part of their data protection strategy, because we all know as soon as you take more than maybe 3 or 5 snapshots of a particular virtual machine, that could potentially start to degrade performance of the actual production machine, which is obviously not a good scenario. For us, we don't have that issue. So VMware does that copy on write style methodology. For us, we do a completely different methodology of snapshots, which is an allocate on write style snapshot, which again, what that amounts to is when we take a snapshot, it's just a small amount of metadata and reference counters when we take that snapshot. So when that initial snapshot happens, it's really consuming very minimal, if at all, I mean, basically no capacity. Of course, as data changes and users overwrite and change data, snapshot does grow over time because we need to preserve the integrity of that snapshot. But we have tested taking over 5,000 snapshots per VM with no degradation in performance to the production machine. So scale customers definitely heavily use the built-in data protection features. Now, of course, you're not going to want to pay anyone to click a camera button every time you need a data protection point. So that's where automation comes in. So if we jump up here to the control center, jump down to schedules, you can see that we have a whole bunch of different schedules created. But if I just look at one that we have created in the interest of time, here, cool thing here is not only are you selecting your RPO, aka your frequency, but you're also selecting the retention for each one of the given rules that you create. So we're taking a snapshot here every 15 minutes, keeping those around for 8 hours, doing an hourly snapshot and keeping those around for 24 hours, a daily at midnight for 7 days, and then a weekly on Sundays at midnight, keeping those around for 2 weeks locally and 4 weeks remotely. We haven't quite gotten to the replication piece yet. I'll get to that in a second, but just keep in mind that you do have the ability to differentiate retention policies on whether you're keeping that locally on the production cluster, or if you're replicating that to a DR cluster or a DR single node. Perhaps you have different, storage capacities. Maybe you have a very storage heavy node in DR. So you want to, have a bit more retention on the DR side than on the local side. You have the ability to do that. So if we determine that's a good schedule for this particular machine, simply pick it from the dropdown, click update. Excuse me. So now for the life of this machine, it will follow that schedule. So far we've only talked about the local protection point or local protection. We also do have the replication getting the data offsite. So if we do a quick summary here from a data protection as a whole on scale, of course, the active data itself is redundant. That's how we have the ability to lose literally any component within the scale stack and continue business operations. To us, drive failures are basically trivial non-events. We understand and will admit that the most likely failure in hardware is when you have a cluster that has spinning disk. Spinning disk is probably the most likely failure that you will experience. And again, to us, it's basically a trivial non-event. We automatically remirror any data that was on that particular drive. We will preemptively fail that drive out if we start to notice any kind of errors on that particular drive, remirror that data. And what that amounts to is just an intermittent loss of IO and capacity. When you reinsert, swap out the new drive that our support team would send out, what that does, there is no RAID rebuilds or parity recalculations like the traditional SANs that you had to deal with, potentially having a RAID 5 and having a failure and kind of having that be a very IO intensive kind of hair on fire moment. For us, that's just not the case. Swap that drive out in. There is no rebuilds that happen. Essentially, our storage layer says, cool, we have a new place to write data, and we'll slowly rebalance that data over time so that that disk will be used appropriately. And then, of course, like I said here, we have the ability to take manual snapshots, and we have the ability to automate those via schedules. We also do have the ability to get a bit more granular on the local recovery capability. So if we look at a machine here that actually has some additional snapshots, this particular machine here has 43 snapshots. So I can go back to any historical snapshot here, and of course I can create a full clone of the machine from any of these point in time snapshots, but there may be use cases where you don't want to necessarily create a full clone. So in that case, you can actually expand any historical snapshot, look within the snapshot, and be able to clone and mount any virtual drive from that particular snapshot back into the same machine or to any other virtual machine that's running on your scale system. So, doing things like maybe restoring an individual file, you don't want to have to clone the entire machine. You just go to that individual drive and clone and mount that particular drive to a different machine, pull that file out, and go about it that way. So what I see a lot of customers do is they'll create like a little utility machine or a backup machine, whatever you want to call it, that can just be powered off, that you go mount drives to and pull files from. To show you just quickly what that would look like, obviously we have 4 drives here on this particular machine. If I wanted to come to a machine here and for whatever reason mount one of these drives over to that machine, I'd simply pick that machine from the drop down and go ahead and hit clone and mount. Now it's going to mount from that point in time snapshot that drive into this particular machine right there, and you'll see that additional 500 gig drive pop up. So last piece here, again, everything we've talked about is local. So if your entire cluster gets destroyed, well, unfortunately, everything we've talked about has been on local storage. So the last piece is getting the data offsite. So that's where replication comes in. So before I click on setup replication, I'll jump over here to control center, down to remote clusters. Here you can see I've created a remote connection into two other clusters. Well, one is another cluster and one is a single node. So we talked about what that single node configuration would look like. So we'll jump over to that. You do get live statistics of what's going on in your remote clusters or remote single node, if there's any type of health warnings or anything, all from this single pane of glass view here under remote clusters. I think I already have it open here. So if I want to go ahead and replicate over to this particular single node, you'll see that this looks exactly the same, except for it's one block rather than 3 blocks because it's a single node versus obviously a cluster. So if I wanted to replicate this machine over, I just go ahead and click Setup Replication, pick US Robo from the dropdown, click Replicate. Now if we jump over here, we'll see that replication process start, and there it is, replicating over. So important to note a few things about replication. Of course, the initial sync is going to be full copy. So if you're dealing with terabytes and terabytes of data, what we generally recommend is that customers set up the production cluster and the DR cluster, DR single node in the same location, get everything replicated over, and then move out the DR node. Some people call that seeding. So seed the data and then move it out. So that way you're only sending over change data after that, after it's set up in your DR location. So that's a very common thing. Also important to note, we are compressing and encrypting the data across the wire, so both bandwidth efficient and secure. And then in the event that you need to fail over, these will probably still be replicating over, probably finish up here any second because there's basically no data. But in the event that you do need to fail over, you'd simply come to your latest and greatest snapshot, most likely. Maybe it would be one from a previous time before that. Come over here, rename it, go ahead and click clone. And within a couple seconds, you have a virtual machine now that's ready to be powered up. Because you'll see these look a little bit different. It's essentially acting as a repository. You don't have all the options here around this particular tile. It's a repository of all of your recovery points, of all of your snapshots. But as soon as you clone one of those, you have a virtual machine that's ready to be powered up and powered on. A couple other cool things. I think I want to finish up here shortly so we have some time for questions. A couple other just last minute things here. From a user management perspective, of course, we have the ability to do a read-only role, full admin rights, but then we also have the ability to do custom roles. So maybe if you have, I don't know, somebody new starting that you want to get their hands on the Scale system, but you don't want them to be able to delete VMs or shut down the cluster, well, give them everything else except for the ability to do that and create a user for them. Updates are really cool from a Scale perspective because we are that entire stack owner. We have the ability to do true one-click updates. So if there was an update available, we're on the latest and greatest now, there would be a big green button here that says apply update with all the release notes listed. If I went ahead and initiated that update, what's going to happen is it's going to start on node 1 in the cluster, live migrate the machines off of node 1 and bounce them across node 2 and 3, apply the update to node 1, and then move over to node 2 and do the same thing. Live migrate the machines off of node 2 to node 1 and 3, apply the update, and so on for however many nodes you have in the cluster. That's why we call it a non-disruptive rolling updates. I have sales guys that like to say, hey, you could do it at noon on a Tuesday. Could you? Probably, but being in my role, I would still recommend doing it at somewhat of a downtime. If you have, at least something that would be considered somewhat of a downtime. But in reality, you can do it really whenever because all of your machines are going to stay up and running throughout the update process. So the idea of having to take maintenance windows to do upgrades is no longer when you move over to the Scale world. And then last but not least, this remote support tab here. I already talked about our support team and how much, they make, or how easy they make my job because we have a bunch of customers like Dan and others that are very happy customers. And generally speaking, that's because if they ever have to deal with support, it's a positive experience. But if you ever did have to deal with support, likely what they would do is say, hey, go to your remote support tab under Control Center. I'm going to provide you a 5-digit code. You enter in that 5-digit code into one of your nodes and go ahead and click Open Connection. What that does is that creates a secure SSH tunnel back to our support server, where then our team can go ahead and diagnose whatever may or may not be going on with your cluster and really take the reins and help you out, rather than, having to deal with some tier one guy that's just, reading off of a script saying, did you try this? Did you try this? They like to just get in there and kind of get their hands dirty, if you will, and really find out what's going on within the cluster. So that is, that's Scale in a nutshell. I did a whole lot of talking there, so hopefully everyone was able to follow along, and we'll see you now and pause for questions.
Thanks, Jared. Hey, I just real quickly, I want to reiterate, kind of go back to the beginning, a little bit about the simplicity of Scale. I come from a background of VMware and Hyper-V, very familiar with complicated SANs, carving up LUNs. That, to me, that's kind of old school. After utilizing this system, carving up LUNs is not fun. Having to deal with support from 3 or 4 different manufacturers is not fun. There's so much about Scale that I've just really enjoyed. You spoke a little bit at the beginning about the simplicity of implementing a Scale cluster that can be set up in an hour or so, a couple hours. I will say that Scale did a really good job of putting together an implementation timeline. Although I didn't really need to use it, kind of like you were mentioning, Jared, I unboxed these things, plugged them in, let them burn in for a couple of days, and then went to, start configuring them. It absolutely only took me a couple hours. I did seed my offsite single node cluster, literally put it in the hands of the IT professional at that member cooperative. He took it in, plugged it in, and away I went. And it's been operating great ever since. So, I can speak firsthand to the simplicity of the system. I know it's a little scary sometimes if you're familiar with Hyper-V or VMware, moving to a hypervisor that's maybe not considered mainstream. But I tell you what, it's got all the features that I was looking for, and it's very, very intuitive. So even if you've never utilized a hypervisor, or if you don't currently have a virtual environment, this is something that will come very naturally to you, and it's just simple to set it up. So just wanted to attest to those things for you. We do have a couple questions. I'm going to turn that over to Ashley. I've got to step out real quick, but thank you very much, Jared.
Yeah, no, thanks for the insights, Dan. Appreciate it.
Okay, Jared, a couple of questions. The first being, I like the idea of removing the VMware tax from my budget. However, I'm fully deployed with VMware. What does that migration look like?
That's a great question. So, as you can imagine, I'd say a good majority, probably 85%, maybe give or take 10% either way, but our customers were previous VMware customers, with the rest being, for the most part, previous Hyper-V customers. So we obviously had to have a really well-planned and well-thought-out migration method for those particular customers. So we have a tool called HC3 Move that we use. Essentially, it allows for really a near zero downtime migration, which is really important for a lot of our customers. So what you do is you install, with this particular tool, you install the agent on your existing VMware VMs, and you build out essentially what equates to a shell VM on the Scale side, and install the target agent. So you have the source on your existing VMware VMs, the target on your new shell VMs that you create on Scale. And what that does is that creates the synchronous process to sync everything, but not only create one sync, it actually keeps them synced in their entirety for, I think the license is good for 60 days. So you have quite a bit of time to choose when to actually do the migration, but it's really as simple as creating that initial sync. And then when you're ready to fail over, you literally click the fail over button. At that point, it powers down the machine on your existing VMware side in this scenario, and powers up on the Scale side. And excuse me, really the amount of downtime is the amount of time that it takes to about reboot a machine, so 5-10 minutes. We also have some other ways, for machines that aren't necessarily critical. that don't need that level of downtime, or that level of uptime, I should say. Maybe test dev machines or just other machines that aren't necessarily critical. You can simply export copies of your VMDKs and import them into Scale. So that just takes a little bit longer, a little bit more downtime, obviously, but there's a multitude of ways. And usually from a pre-sales perspective, I myself will help, make those decisions alongside of the customer of, what the appropriate migration process is going to be.
Okay, thank you so much for that answer, Jared. Final question here before we log off with this webinar. Do you partner with any cloud providers for, I know I'm going to mess this up, DRaaS? I don't know what that means.
Yeah, I think they're referring to DR as a service. So yes, we do. So I briefly mentioned it, but I didn't go into any detail, so I'm not surprised that question came up. So we partner with Google and GCP, Google Cloud Platform. The product that we call it is Cloud Unity. The cool thing about it is even though it's through Google and it's running in Google data centers, you don't actually have to deal with Google at all. You only have to deal with Scale. It's essentially a virtual instance of HC3 running in a Google data center, but it's all procured through Scale. It's all set up through us. And another added feature or benefit of that particular offering is we're actually handling the ground to cloud networking on that offering as well. We're using a VXLAN overlay so that the node IP address of the node that's running in the cloud actually appears as though it's on your local network. That makes things a lot easier from a failover perspective in the event that you actually have to use it. Hopefully you never do, but if you do, it makes that failover process that much easier.
Okay, thank you so much, Jared. Again, I want to thank you for joining us today. Thank you to Jared Pexa and Scale Computing for the information this morning. Our next webinar will be starting at 10:30. It's Distribution Situational Awareness, provides improved system reliability and member satisfaction. We hope to see you all there. Again, thank you so much for joining us, and hopefully see you back here at 10:30. Thanks, you so
everyone.
much, Jared.
Thank you. Bye-bye.